Okay. Today we'll cover mostly two areas of networking. One is quality of service, another is simple network management protocol, and also cover device management protocols, which we have already covered in the previous session. Okay. Now we'll begin with quality of service. Okay. Quality is very important in everywhere, whether it's a product or a service. Okay. Here we are talking about service. That is networking service quality. So what is quality actually? Quality is actually the perception of users or consumers about their service or product or service. Okay. Some product or service has some quality. Okay. So we want to get that quality in general generally we want to get maximum level of features. Okay, that is quality in general sense. Okay, but in reality quality is actually quality depends on your product category. If you buy different product that is not at the highest level, so you will not get the highest features or different attributes. Okay. So if we talk about quality of service of networking, its aim or objective is to ensure that your networking services are up to your expectation, or you are satisfied with the networking. So we will go through this. So QoS, quality of service, is an area of networking where we will discuss different tools and techniques that will ensure quality of experience. So, what are the issues with network? Sometimes we download, we don't get enough bandwidth. Okay, sometimes we call, but our voice is not clear, or there are some delay or latency issue that hampers our interactive voice experience. So these are the quality issues in networking. So we have to ensure with different tools. So if I talk about the definition of quality of service refers to tools that network device can use to manage several related characteristics. What happened to a packet while it flows through a network? When packets passes through network, different routers and switches, how they will be treated in the devices are actually quality of service. Okay, so they use different techniques to make your experience better. Okay, quality of service defines this section as per hop basis. Per hop basis means point to point. That means one router is connected to another router. So this is one hop. Different techniques are applied on this hop actually. Okay, another hop will take will or may take different approach. Okay. So what are the issues of quality? Okay, 4 characteristics of network traffic. You must memorize actually, or okay, let me memorize those features. One is bandwidth, speed of a link. If your bandwidth is not that much to serve your purposes, you will not be happy. You will face that your files are not properly loading, your web page is not properly loading. So there will be delay, noticeable delay, and your experience will not good. So bandwidth is very important for a service. In the past, when internet came in our country, we experienced very slow bandwidth. We clicked a web page. It took time to load the page. So that was an issue. So that was actually related to infrastructure issue. Our infrastructure was very poor at that time because it was initial stage and different legacy technologies are in use. Some had very limited bandwidth capability. But now our technologies have improved significantly. So we can have bandwidth. But in a network, different services share the same bandwidth. The bandwidths are being shared or distributed. Okay. Then another issue is delay. Say when we send data to destination and it takes time. You know that data goes through the network at around the speed of light, but there are some other delay due to processing of at CPU of routers to each other devices. Okay, so distance for distance there are some delay, but that is not that much. But delay comes from different source. Okay, number one is for traversing your signal over your medium. For example, optical fiber cable, there is 100, suppose 100 kilometer long fiber cable. So data is traversing through the cable at around the speed of light. Okay. When it reaches to the router or switch, there is a queuing delay because these packets may not immediately process. They may have to be in the buffer, okay, for processing. So there is delay. Another delay can be in the process CPU for processing. So if you have a very slow processor, then there will be delay. So there are different sources for delay. So a delay is very high, and your experience will be very bad. For instance, in the past, when we had to submit call for through satellite, there was delay, huge delay. So when we called someone from Bangladesh to USA, for instance, we faced very poor telephone call experience. When I call, I say something, other side listen it after some time. So significant delay and it was noticeable. And then another issue is jitter. Jitter is one-way delay between consecutive packets. Okay, you may face jitter when you are sending, or receiving, actually receiving packet, one packet with some delay, another packet with more or less delay, different delay. So it is also disturbing for networking services. Then another factor is lost packets. When we are sending packets over a medium, whether it is copper, Ethernet cable, fiber optic, or microwave, radio wave. Okay. There may be some lost packets. Some packets will be lost for some disturbance at physical layer. Say some maybe some disturbance due to electron movement due to heat, for example, in a media for some reason. So it will damage your packet. So destination and device may not recover the packet or signal. Okay. Or in case of radio link, there may be interference from other devices, intentionally or unintentionally. So packets are lost. So it is another area. So so cost tools impact bandwidth, delay, jitter, and loss. So cost tools are used actually to manage these 4 issues. Okay, how those issues impact our experience, we'll discuss. Okay. Now let's look at different types of traffic in the network. In the network, there are different types of networks. For example, one is data traffic. Data traffic, example of data traffic is HTTP traffic. When we browse website, we have to transfer data between client and server. Client is our browser on our computer or our device, and the server, web server. Okay. So if there is no enough bandwidth, you will not experience good internet browsing. Okay. So what is critical here? You need enough bandwidth for this. But delay and jitter, to some extent, will not impact your experience that much. So if you are clicking a page to load, if there is some delay, say there is 200 milliseconds delay. So it may not noticeable for us, maybe tolerable. Okay. Jitter also will not hamper that much. So here you need bandwidth. If a web page is very rich with the graphics, for example, then it may need enough bandwidth. So bandwidth is important here. Another is another type of service is bias. So when we are talking about with this in this session, for example, we are using Zoom video conference. So here one service is bias. So bias is not clear, then our experience will not good. So it is bias over IP, VoIP. So VoIP needs only little bandwidth. When our voice traffic or voice data transferred over network, that takes little amount of data. Okay. So they don't need enough bandwidth. They need some kbps range data, some kilobytes, kilobits per second. Okay. But if there is delay is 150 millisecond, more than 150 millisecond, and then that case our listening experience, hearing experience will not good. It will be poor experience, or jitter or delay variations will be within 30 milliseconds. And if there is packet loss and our listening experience will be poor if we have packet loss more than 1%. So one packet per 100 will be allowable if we are transferring voice traffic over network. So you can go through this data, or at least you can understand that this range are relevant to this type of traffic. And then we have another traffic bias apart from data and bias, we have video streaming. Okay, but video needs higher bandwidth. Okay, so suggested quality service requirement for video bandwidth should be 384 kbps to 20 mbps. So huge bandwidth is required for video streaming because there are huge information needs transfer. Say video needs frames per say 20 frames per second, and should be transferred, say, for example. So in that case, you need to transfer different frames. So it takes huge bandwidth. And delay can be 200 to 400 milliseconds. So it has more capacity to sustain delay compared to voice. So in case of voice, okay, in case of voice, we had to maintain 150 millisecond or less. Okay, but it can video can sustain 200 to 400 milliseconds, and jitter can be 30 to 50. But in case of voice, it should be less than 30. And packet loss, okay, packet loss is also the same compared to voice. So these are requirement for voice, video traffic. So in broadly speaking, there are three type of traffic: voice, video, data. But we can classify further levels. But for CCNA, we should be within this type of traffic for our discussion. Okay. So here, data versus voice. Data applications generally tolerate more jitter and loss than voice. Okay. A single voice call does generally takes less bandwidth than a typical data application. But bandwidth requirement is consistent. Data application tend to be bursted with data burst in reaction to user doing something with application. So when you are passing data traffic, it can be bursted. Burst means sometimes it will spike. Okay. Say you are sending FTP, you are sending file to FTP protocol. Okay. Suddenly you are sending high rate of data. Okay, a large file you are sending. So that is why it is called burst. Okay. Do you have any questions up to now? Quality of service is very tough concepts. Actually, it is very critical, and you have to study in depth to understand many concepts. However, with this presentation, I tried to make everything easier, at least with regard for CCNA level. And with this knowledge, you can advance your knowledge through studying and some practical activities. Okay. Up to now, any questions? What about Mohammed Dizzy Brain? What about Ali or C2? Can you hear? Oh, one thing. Okay. We started. You requested to create a Google Drive location for all the resources. Okay. I created a location and uploaded all the documents in the cloud. Okay, I will share the link. And okay. Okay, if you have no question, let's move on. Okay, we have different tools for quality of service. One is classification and marking, and queuing, shaping and policing, and congestion avoidance. So what is classification and marking? Classification is actually matching the fields in a message to make it choice to take some course. Say different traffic have different attributes. So based on that, we will classify them. Say we have bias traffic, we have data, we have video. So based on different attributes, we will classify them. Okay. So how can we classify if we talk about the packets? So packets have different headers. Okay. And then they have payload. Okay. Like a letter has when we send letters using courier service or post office, you have to write a letter, and that you put in an envelope. On envelope, you write some destination. Source address, destination is your destination. Okay. So source, destination, etc. are mentioned on your envelope, which is header, and the letter itself is inside the envelope, it is payload. Okay. So envelope has different information, source and destination, and another would be marking. Say when you go to courier service, post office, there are different options. Do you want to send your letter or your parcel on a regular service, or use express service? Okay. So sometimes if it is urgent, you say that yes, I need express service. Okay, for that you have to pay more. Or you say no, it's not that urgent. Yes, regular service is enough. Okay. So these are information. Okay, for quality of service, keep in mind this example of letter or parcel. It will help you greatly in understanding this thing. And the packet is for packet, we can use this example of envelope. Header, envelope is header, and the payload is the letter or the parcel itself. Okay. So how then now you think that post office or parcel courier service people can process your letter or parcel based on the information of header. He or she has no access to the letter itself, or they don't need to see for processing. So which are marked? So marking is, what is marking? Marking is some information on the header. So when we send letter, on the letter, when you say I need express service, then the put mark express or the seal, put a seal on this letter, and afterwards the thing they will identify that this is express, this is regular or other. Okay, so marking is important. Yes. Do you have any question? Okay. So marking is like this on the letter. Here in the packet, in case of packet, it is header. So what is header? If I already showed you, or you know, that in the header there are different fields. Say source, address, destination, and there are different types of service. So one field is relevant for discussion is type of service in IP header. So in type of service there are how many bits? There are 8 bits. Okay, there are 8 bits. Out of them, there are also three bits for IP. IP precedence. Precedence means priority actually. How you prioritize your packet. So those packets need express service. You will prioritize them when in processing. Okay. So maybe it's not clear. Okay. Okay. What is happening? Actually, there may be some. Okay. This slide should be better. Okay. When we send traffic over trunk link, there is 802.1q header, which is out of there are 3 bits can be used for qualitative service. Okay, qualitative services per hop basis, that is PHB, per hop behavior. Okay, so there are another marking options is in IP version 6 and IP version 4. There are DSCP field in IP header. There is IP precedence in IP version 4 and IP version 6. There are 3 bits, and there are CUS when we are talking of VLAN trunk. There are 3 bits TID over Wi-Fi. When we send traffic over Wi-Fi, we can also configure quality of service over Wi-Fi, and in MPLS there are EXP bits. Okay, so just get some idea with this table. So how this is done? Okay, look, in this picture you have a computer from where you are generating data or packets. Okay, you're generating packets, different types of packet, data packet, voice, video. Okay, it is connected to a switch. At the switch, you have some quality of service configuration, and at first it will catch the packets frames from your computer. It will mark. So if it is voice or video or data, based on this classification, it will add some value, differentiated service code point. It will add some marking. Okay, why they are marking? They are marking that okay, this packet should get precedence. Okay, it is voice traffic, so it should get precedence or priority before data traffic, because if it experiences delay and the service will be poor. Okay, for data traffic, it can get some delay, or for data traffic, it needs more bandwidth. So for these purposes, they are providing some marks. Okay. So, and the next switch loop, and it can see the DHCP one mark is DHCP X, one has DHCP mark Y. Actually, it will have numerical value, not alphabetical mark. So based on that, it will classify. Okay, DHCPX, then it is class 1, or it is a different class. Okay, so based on marking, you can classify. Like the letter, which are regular, it will be in regular class, which has express marking, that will be express. Okay. So this way, marking and classification. One. Okay. This is the main technique. Okay. But marking will be provided in IP packet, and so marking are done at different system based on header values. Okay, because you know that when you talk about Ethernet layer 2 frame, frame has source address, destination address. Source address is MAC, source MAC, destination address, destination MAC, and other fields for different purposes, and some are just for our quality of service marking. Okay, quality of service marking is for just to mark your packet. Without marking, classification is not possible, and based on the classification, different policies are configured. So in normal network, we don't configure quality. We don't care. Okay, but in large organization where you have VoIP, telephony, you have voice service, data service, so quality of service is required there. Otherwise, service experience will not good. Okay. So for marking, differentiated services port point, DHCP is used. Okay, it is just code at layer 3 IP protocol. Okay, and there are different DHCP values. There are different DHCP values. So these are actually long discussions, but to cut the long story short, we can go through this. So there are expedited forwarding, EF. EF is used for low latency, low jitter, and low loss packets. Such as for voice, expedited forwarding is required. Expedited forwarding, you can, I think, is express forwarding, for example, in case of letter. Okay. So when voice packets are arriving at the router, it will expeditedly forward. That means it will take it will put priority on the packet and said that, okay, it's voice, I'm transferring or processing it before other service. And there are other values, AF4 something, AF3 something, AF2 something, and CS0. So this type of marking will be used for different types of service. For interactive video, we can use AF4X. For X means actually different value. There are different values. For streaming video, another. Okay. So in this way, we classify, mark and classify different packets. So it is a summary. What should we assign at layer 3 and layer 2? So for voice for voice payload, we use EF, Expedited Forwarding, and class CUS, class of service at layer 2. It will be 5. Okay. For video, it will be AF41 and then CUS4. Okay, for business critical data, in case of data, okay, you have email, you have a different file transfer or web, you will assign them AF21, and for layer 2, use 2. It will you will configure. So in general, 3 are mentioned here, but there are many. So where full POS settings are configured, there are even 100 or more configurations because they classify more granularly. So they use different levels of marking and classification. Okay. So another technique POS is using is queuing. So you know that when packets are coming to a router cannot process every packet at a time. It will put the packets in its buffer, okay, which is actually RAM in its memory, and that case you processor just process those packets. Normally it will process first in first out basis, but if we are configuring different quality of service level, in that case it will schedule packets based on different scheduling mechanism. So first in first out scheduler is very simple and normally it can be used, but it will not ensure your service experience level. Okay, it will treat everything equally. Say it has voice, video, data, everything will be created alive. Okay, but you can use different scheduling, round robin scheduling, prioritization, and taking turns with each queue. So there are different queues, say voice queue, data queue, and you have video queue. Okay. In that case, you can set some prioritization. Say your voice 20%. Normally, round robin means it will just turns to each queue one by one. Okay. At first Q1, then go to Q2, 3, and then it will take turn. But you can prioritize with some words. In that case, it will prioritize some say voice queue, it will take 20%, 60%. Then it will take 20% from other. In this way, it will work. But it is not sufficient for voice service or video. So there is low latency queuing, LLQ. It is required for voice or VoIP services. And when you use LLQ queuing, in that case, it will prioritize low latency services. Okay, and then we have class-based weighted pair queuing. Okay, class-based class-based queuing ensures bandwidth for different classes. Okay. In this way, when packets come, it's conceptual diagram. When packets come, the classifier will classify all the packets. Okay, classifier will classify. Okay, it is voice packet. Okay, go to the voice queue. Your data packet. Okay, go to data queue. Your video, then okay, video queue. So here we are shown, but in reality it may be more based on your configuration. Then scheduler will take packets for processing from this queue based on which scheduler you are using, and then it will process and transmit data to the next hop. So this is actually queuing mechanism. So this not what I'm trying to say is that first in, first out is very simple, and it is not used when you try to differentiate processing of packets based on their marking and classes. Okay. So different queuing mechanism is needed. Okay, another important concept is shaping and policing. Okay, we discussed different one technologies or one connectivity. So look at this picture. You can see that there are two routers, router 1 and router 2. In between there is some one connectivity cloud. It can be Metro Ethernet, it can be MPLS network, and whatever. But when you contract with a service provider, they will give you different options, and you will purchase a specific bandwidth from them. Say you need in this picture 200 Mbps link you are using. Okay, but their network or the network may be 1 Gbps. Say your router to their router or switch, the link is 1 Gbps. That means 1000 Mbps around. Okay, so what if you were sending 1000 Mbps data to the service provider, but service provider are told you that you have to pay for 200 Mbps. So what they will do some policing. Okay, policing means what police do? Police do who are going beyond the limit behavior police take action. Okay, similar way, here is policing. In the service provider network, they will discard the data that you are sending in excess of the agreed bandwidth. Here is CIR. CIR is committed information rate. That is service provider committed to provide you 200 Mbps, not more than that. If you send more than that, because you have 1 Gbps link, which is capability to send more data to service provider, but service provider will not allow, they will discard. Okay, so when they discard the excess packets, your service will be poor, because there will be packet loss, because your service provider will intentionally discard packets. So how they do, and look at the picture below this diagram. Incoming packets are there, but dotted line you can see is the CIR, committed information rate, level of information data allowed. So they will police on this data. So they just cut in excess or above the line will be discarded, and you will lose your packets. Okay. But at some point, they will allow some data. Sometimes they will allow some data. Okay, that is worse. Okay, but that is not always. But for very limited period, they will allow some data. Okay, but mostly they will not allow above CIR. So what you need to do, you have to shape your data transfer. So you will not send excess data to the service provider. So before sending, you will shape. You just shape your bandwidth. So how you will shape? Say for if we talk about 1 second period, so you will what you will do? Say 1 second equals actually 1000 milliseconds. Okay, 1000 milliseconds is 1 second. Okay, so 200 milliseconds you will send 2 Mbps, 2 million bits, and then 800 milliseconds you will stop it. You will send nothing. So in this way, within if you consider 1 second, then you are sending 200 Mbps only. For next second you will do the same. For the next second you will do the same. So so in this way your packets will be shaped according, and it will match with the data rate that is committed with service provider. So there will be no problem. So you are not sending excessive data to service provider, and service provider has nothing to discard. Okay. So you can do it in a different ways. For example, you can send 200 bits in. So you can divide it according to your requirement. Okay, that is the case. Okay. So, ultimately, your target is you will not send 200 million. You will not exceed 200 million bits per second. Okay. And another technique is to avoid congestion. How congestion occur when there are many packets are coming to your router, and router cannot handle all the packets. So congestion occurs, and there is one term tail drop. Tail drop means the last packets that come, but there is no place in the queue, and those packets will be discarded or lost. So to avoid this, some techniques are used. So there are some thresholds. If threshold is if the number of packets are within the limit, then no drop, no packets will be dropped. But if it is between maximum threshold and minimum threshold, then different levels, percentage of packets will be discarded, or when it reaches the maximum level, and the packets will be dropped. So in this way, some packets are number of packets are reduced. Actually, congestion avoidance mainly relies on TCP's windowing mechanism. You know that in TCP connection, when TCP sends some packets, it waits for acknowledgement. Okay, it's sending one packet, then wait. Okay, it is acknowledgement. Okay, it is this is acknowledgement. Otherwise, it will retransmit the packet. So sending one packet and receiving acknowledgement is not efficient way for TCP. So what they do, it will use window. Window means at first it send one packet, for example, and receive acknowledgement. That okay, good. Then it sends two packets and then wait for response. And in this way, it will send many packets before receiving acknowledgement. Okay, so that is efficient. So in case of congestion, it can sense that some packets are lost. In that case, it will reduce the window size. Okay, window size is actually the number of unacknowledged packets. Okay, in TCP. So to some extent, it behaves in UDP. In UDP, you are sending only packets, don't need any acknowledgement. But TCP need acknowledgement after some packets. Okay. So use this mechanism here also for congestion avoidance. Okay, do you have any questions, anything about cost?
What is the meaning of ECN?
Oh, ACN is actually okay. For congestion control techniques, what is the elaboration of ACN? Congestion notification sum. Okay, use some congestion notification. If there is any congestion, it will take some preemptive measures. Preemptive measures means if it receives some congestion notification, and it will take actions based on that and adjust its transmission. Say you know that your transmission path has some congestion, you will adjust your transmission. Okay. So these are different cost tools are used in quality of service mechanisms, and you have to go through all the materials of CCNA. But here I just mentioned the main techniques, but in brief. Actually, they are very long topic. You have to read, for example, on cost, you will find different books. Okay. Or if you study CCNP level, you get more details. Okay. And another topic we will discuss is the Snmp Simple Network Management Protocol. Okay. What is this? In network, if you have a large network, you have to install network monitoring system. Okay, what is happening in your network? And you have to regularly check your health of network. Okay. So you have a network, you have 500 routers, switch in your network or other devices, a firewall or kind of thing. And you have different fiber links, you have different connectivity, etc. So, and you have Wi-Fi network, you have many things in your network. So, what is happening in your network? Maybe your Wi-Fi router, Wi-Fi access point is down at some places. Some users call you that your device is faulty. They are not getting service, Wi-Fi service, or somewhere a switch is down, or switch has some alarm. Okay. Many things can happen. So logging into all the routers and switches for checking is not possible. So what we do, we use the different monitoring tools. Say Nagios, one example. If you install a Nagios server and configure all the devices, and you can monitor all the things from a central location. So from a central monitor, you can see what is happening, whether your routers are operational or any Wi-Fi device is down. Wi-Fi device means Wi-Fi access point is down, you can see it. So now how this Nagios server or central monitoring server can understand that this router or this thing has some problem, how they can. So it uses Snmp protocol for communication. Okay. Snmp protocol is running on all the devices. Okay. Say it may be a printer, for example, there is a Snmp protocol running. So for some reason, if you want to see or gather information about the printer, whether it has any problem from remote site, or if you want to see your Wi-Fi access points are operational, you can use this protocol. Okay, but in simple term, you can use ICMP also, or whether a device is at least live or not. But with Snmp, you will get many information, such as if you have any problem on the device, say device is faulty, for example, or has some error or any problem, and those message logs will be generated, and you can get this information from your central server. Okay, these agents. So, okay, these agents have to be enabled here, but normally in most cases Snmp servers are enabled, but you have to configure it. That your central monitoring server are with monitoring server you have to integrate it. Okay, just configure at your server end and you at your device. So in that case, they will communicate and gather information for you. So from central monitoring, you can see all the problems. So Snmp has three main areas. Three Snmp manager, Snmp device, and Snmp agent. So another is an Snmp management information base, which is in the Snmp device. So mostly we are talking about two entity, physical entity. One is Snmp manager, or say here Snmp base, monitoring server, and managed device. Managed device means your router, switch, Wi-Fi devices are managed device. You can manage their configuration. You can manage or monitor their problems from a central device. So management information base includes all the information in the device. Okay. So Snmp manager's function. What is Snmp manager? Queries agents. Okay, gets response from agents, sets variables in agents, and acknowledges asynchronous events from agents. Okay, how they query on a periodic basis. Snmp manager query. Okay, what are the problems or this type of messages are there? Okay, and if there are messages, we get from devices. Okay. The queries measure agents. Agents means agents are in the managed device. Okay. And managed device, which are managed device? Managed device are the device that you want to monitor and configure. The router, switch, servers, workstation, printers, UPS. Okay, sometimes UPS has also Snmp agent. So you can also monitor UPS in a data center. Okay, because data centers have very smart online UPSs that provide backup parts. So you may need to monitor all the UPSs problem, and you will integrate them in your network, TCP/IP network. So you can monitor the voltage level and the current level that are consuming by your data center. So everything can be monitored from your system, or if there is any fault in the UPS, so you can monitor from your monitoring, and if there is any monitoring, you can take actions. Okay. And Snmp agent package in network elements which are available in your networking OS. Cisco iOS has a Snmp agent. Okay, you will get it. Okay, just configure. So what it does, what is the function of agent? Agent management information from about this local environment. Okay, from router's own environment, it can and collect different environmental information and stores and retrieves information in the management information base. Signals as even to the manager. Okay, sometimes it sends the message to the Snmp manager. Okay, normally Snmp manager queries, okay, do you have this kind of message periodically after a certain period? Okay, but it is possible that agent also proactively send, okay, I have this message to manager, Snmp manager. Okay, that is called Snmp trap. So, for example, what type of information Snmp agent collect? For example, of a router. Imagine a high-end router. So you have to monitor the processor utilization. Say what percentage of router processor are used. Say processor use 90% CPU is utilized. So in that case, you have to take actions to upgrade your router, because it may require more percentage. If it anybody anything asking anything? Okay. So if it reaches what you are talking. Okay, if you are not talking, mute. Maybe Mr. Motion, maybe. Okay, it is not mute. Okay, is it going? Okay. It will collect the temperature, for example, say router, CPU's temperature, or it can other environment such as humidity of the room, if sensors are integrated. So all this data can be collected by Snmp agent, and from central Snmp manager, you can get all this information and take actions based on this. Okay. And generally, this is the conceptual diagram. Say you have a Snmp agent. In agent, you have different management definitions of what type of data you need, and management database. Yeah, and where these are Snmp agents are there in servers, in the routers, switch, Wi-Fi, desktop, anywhere you can configure it. Okay. And there are two types of communication. One is Snmp manager queries information from okay, maybe it is echoing for some reason. Okay, maybe motion. Okay, this let's solve. Okay, whether I can mute him. Equals so could be or as mute option. I'm not getting mute option for him. Okay, only one motion also motion. Why this option is not working? Okay. So Snmp managers work in this way. Then management information base contains standard set of statistics and control values defined for hardware nodes. Okay, different vendors management information base can be slightly different based on their modifications. Okay. So these, okay. Another important, most important concept, okay, Snmp another concept is Snmp version. Okay, it is very important. You have to remember Snmp has 3 versions, broadly 3 versions, but there may be other versions. But we will mostly focus on these 3 versions: version 1, version B, version 2C, and version 3. But version 1 and is very old version. It is the initial version. Okay, version 2C is still in use, and version 3 is latest version. But to make our network secure, we should use Snmp version 3 only. Snmp version 2C also vulnerable because it doesn't provide any encryption. Okay, Snmp version 3 can provide you authentication and encryption. Authentication means you should have some key, for example, for password. Okay, some sort of password protection, and you can create it for a specific user also. And you have also encryption, and that means you have encrypted traffic, so no one can see what is transferred between 2 nodes, between the managed device and Snmp manager. But version 2 provides authentication to some extent. It is community based. You use community string. Community string is a kind of password, I would say, in the sense that for a group of device can use that Snmp with this string. Say you say some string and all the entities in the community use the same. Okay, there is no different password. Okay, for every device. So that is the limitation, and also it has no encryption. So traffic is in plain text. So whenever you use Snmp, you use Snmp version 3. Okay, otherwise it is a problem. And all the latest devices have Snmp version 3. So never use version 1 or 2C. And those Snmp version are still in the newer devices because they want to be compatible with older systems. Okay. So another topic was in our schedule is device management. So for device management, there are different protocols which we have already covered in the previous session. For example, for router and switch and AP configuration, we use SSH and Telnet and HTTP, HTTPS, 4 protocols for configuration. HTTP and HTTPS are GUI based and command based is Telnet and SSH. But HTTP and Telnet are using plain text protocol, so we should avoid them because they are not secure. We will use SSH and HTTPS. And another thing is Ntp and Syslog. We use Syslog server for preserving logs to a central server, a Syslog server. So in case of device are damaged or lost for some reason, we can get some information from Syslog server and can be used for analysis later. Okay, so Syslog is important. Another is Ntp. If we don't have same time for all devices, we will not correlate different events happening. Okay, so every devices in an environment should have synchronous time, same time, using a Ntp server. Okay, that which will provide time to all the devices. Okay, and okay, these are the main network device management protocols, I would say. Okay. Okay, we already discussed them. Now we would look at some for just for understanding. But these labs are not actually full fledged, I would say. Okay, because packet tracer has its limitation. So we have 4 labs. One is the Snmp version 2 based, one is version 3. In fact, we will use version 3 in practice, and then we will do some quality of service and Syslog. Okay. Okay, let's discuss. Although you can do it if you follow this manual. We can have okay. In this figure, we have a router and a server. Okay, so we will use what we are trying to do with this lab. Our objective is to configure a Snmp on the router for a Snmp manager. Say this server is a Snmp manager. Okay, imagine you have a monitoring system where you can monitor your router of your router. You have router in a large and they are dispersed in a large geographic area. Okay, so you have no other option on without a monitoring system. If you have one or two router, okay, no problem. You can log in to the router on periodic basis, see what is happening, whether router is being heated. Okay, you know, electronic devices malfunction if they overheat. Okay. So you have to monitor every environment factors. Okay. So you are, or any link is down for some reason. Okay, you can see from this server. So this server is not functional, although we can integrate in the packet tracer. Say, look, and this way, okay, and you are taking a server. Okay, server. So let's configure all the IP address for networking. 162.1.1. Okay, let's consider configure the router. At first, your network configuration. So, interface gigabit 0 is there. IP dot 171.1. No short. Okay. If we go to the server, I can set where IP address system. So 1.2 is at server. Okay. Okay. Hope this is reachable. Router is reachable. Okay. So now it is reachable. But look at services available in the server. Look, there is no Snmp. Snmp manager, kind of. Okay. So we have nothing to do from Snmp manager's point of view. What we'll focus just how we can configure our router so that it can communicate with Snmp manager. So what are the commands? So in the okay, command is Snmp server community public RO Snmp community private read write. Okay, look. So RO is the community string. So there are in practice there are say two options. One is public. Public means anyone with RO. RO means anything you can write there. This is community string. Okay. With whoever knows this RO community, say whatever you say here or write, they can get public access. Public access is actually read option. Okay. And private, for private connections, you have another community. Okay. So we just run this command. Okay. It is so Snmp agent and host router is undergoing warm start. So Snmp agent will start. Okay, Snmp is there in the uh, Cisco router, no problem. But you have to enable it with community. Okay, okay. For private, you can also configure. But you have another security feature. That is, you can use access control list (ACL), who can access this Snmp service. Okay, who can communicate with the Snmp agent in the router. So if you specify in the SCL, say in the SCL, so in the SCL, look the command access control list 10, that is, it is standard. And then what is the action permit? You will allow a IP address of the manager. Okay. So you just write SCL. Mention that this you can also use a network. Say you have 5 IP address or something that you want to allow. You can specify in the access control list. Then how can you execute this list? So command is Snmp server community private read write, and then 10. 10 means access control list number. Okay, maybe there is some keyword issue. No, somehow it is not running here. However, in this way, we will run the Snmp. Let's look. So run. Which commands are in the Snmp server command is there, access control list is also there, but why Snmp server? Look for you, server copy Snmp server. Okay. Let's take help. Then what is the command? Snmp community is there. Okay. Then what is the command? Then what? Community string. Say here RW. Then what can and then then read write. Okay. Say RW. Okay. Okay. There maybe now there. Community string RW. Community string was RW, then RW. Okay, here it is not running somehow. Then, okay, it's not running in the, but understand the concept. How we enable Snmp version 2. Okay, look at the version 3. What are the sorry, and here Snmp version 3. Same setup, but look at the differences. Why we call this feature? Okay, So let's look whether these commands are running. Commands can be executed. Let's remove all the commands I used in for Snmp version 2. Okay. To ensure that there is no conflict between them. Okay. Okay. Then I should remove this one also. So no, before the command you use no just to remove. Okay. And now I also remove that control list here. Maybe I will use new one. Okay. Okay, done. Okay, let's look at this. How Snmp version 3 is there. Okay. Here is let's decide where which will be allowed to communicate with Snmp as well. Which okay, this is another security. Okay, you are not allowing everybody. Okay, you just allowed the Snmp manager. Then you Snmp server group read access version 3 private PRIV keyword is used for privacy. Privacy means confidentiality. Access 10 access 10 means you are allowing this SCL. Okay, whatever you are writing in the SCL which are allowed, permitted or denied will be effective here. Okay. Okay, first we are just, oh, actually it is not working also. But, well, Snmp server, then what is there? Okay, now okay, let's check. Maybe Snmp. Okay, let's run this command first. What is it? Okay. In this command, what we will use Snmp server, then we will use user. Say you have CCNA admin. This is username. Okay. In Snmp version 2, we use just a community. Why it is called community? Because a group of devices or community can use the same agent and communicate with them, communicate with the agent with that community string. But there is no option for user creation. But in version 3, you have user creation. You can use a specific user, individual user, individual password. And what type of access you are allowing? Say access, read access or write access. Okay. And what are the version 3? Version of this system, it is version 3. And then you are use authentication SHA. SHA means hash algorithm. Okay. And you are using a key, some key, Cisco. Then you are using password. Say privacy. Privacy means for confidentiality, so that no one can understand. Yeah, and then DES 256. What is this? It is a encryption protocol, although it is very old encryption. It should not be used. Okay, Cisco AE 123 is password. Okay, let's see whether it is running. Okay. Okay. Okay, it is also Snmp server. Okay, server is available, and then let's see what is there. Okay, Snmp enable Snmp enable. Let's see. Community okay, from help you can see everything. Maybe some limitations. Okay, but if it is executed properly, then you would see Snmp user. Okay, Snmp user can be shown. So username would be some given name. Then engine ID is automatic generated, auto generated, and a storage type non-volatile active. So those data is in non-volatile form. And authentication protocol is SHA. SHA is hashing algorithm. So your authentication will not be in plain text; it will be hashed. And confidentiality privacy protocol is DES. And group name, if you have a group and read access group. Okay. And if you want to see the group in separate way, and then you will see that the name and details. So active access listed. That means you have created a access list. So Snmp group is associated with this access group. So no other devices mentioned not mentioned in the active access list will not be able to communicate with Snmp and SNMP. Okay. So this is the difference. Okay, in practical way. Okay, but it is not running. Maybe SNMP is not properly activated. So SNMP related part of the show open now. Okay, great. So then is there any SNMP related? Okay, so SNMP statistics there. We get nothing. Okay. Nothing actually. Okay. So this is the difference mainly. Okay. So keep in mind that SNMP version 3 should be used in production environment. So we have another course related lab. Okay, do you have any questions on SNMP or anything? Maybe not. There is another lab. You can do it yourself. Here, we are using different course functionality on a router. Okay, there is two routers. Okay. So there is ACL telnet. So how telnet traffic will be classified? Okay, here we will classify a traffic, and okay, in the beginning we discussed classification and marking in quality of service. So what we do, we mark different services for different for treatment, for differential treatment. Okay, not equal treatment. Okay, in reality, we always want equal treatment everybody, but here we are talking about data traffic. The data traffic has different purposes to differently. So in this lab, we are using classification. Okay, it's another approach. We are not marking here. For marking, you may need more sophisticated lab. So in this lab, we can create extended IP, extended ACL. Okay, in extended ACL, here we use named extended ACL. A name extended ACL use a name for ACL identification instead of number in numbered ACL. Okay. Here, say telnet ACL is your given name. Okay. And then you permit TCP any to any, and then equal to is 23, that is telnet. So you use another concept, class map, match telnet. Okay. So here you will match access group name. This command syntax is used to match this telnet ACL. If your traffic is telnet ACL mentioned in the access control list in ACL, then it is match telnet. It will be match telnet. Okay, it is class map. Why class map? We are using we are classifying the traffic using ACL. Okay, using ACL we can classify traffic at layer 4. Okay. Now we will apply policy. So policy map, then we will go to policy map. Policy map is classify telnet. Classify telnet class is from class map, that is match telnet. Okay. And now we apply the policy map to the interface. Where is the interface? Interface gigabit 00. So we are doing everything in router 2. Okay. Because router 1 is host. Say router 1 is traffic. So providing or sending traffic, and we are applying different policy at our router. So in router gigabit 01, okay, no, we are classifying in router 2, and we'll send those traffic with this classification to router 1. So what we is the command syntax service policy input classified telnet. Policy is applied to the interface. So when the traffic comes to the router, it will apply this policy or classify the traffic, and the policy will be applied in the interface. Okay. And when we see the policy map interface, on the interface, we will see let's look. If we run the command, is our router, what it will see, it will show, it will see nothing. Okay. Okay. Gigabit, nothing. Okay, it will show nothing. When we apply this policy, and then you will see that all the packets are classified. Okay, telnet. So why you are classifying telnet? Because you want to specify a policy, say some specific policy for telnet. Say you want to prioritize your telnet traffic over other traffic, so that you can easily telnet your router. So this is the objective. You are classifying those traffic separately. Otherwise, all the traffic are mixed, and as usual, it go to the router or elsewhere. So to identify the service, you are just classifying. Okay, let's look whether this type of commands are okay. Extended, it will prove it work in our last lab. Let's run. Okay, mostly understand the concept here, and then we permit and the SCL. It will work, no problem. And then we are going to classify. Okay, understand this types of commands, how they relate class map, ACL, and policy map. Okay, how they interrelate using a different keywords. Then math. Look, when you do some programming in C or C++ or anything, okay, there are some logic, okay, we utilize, okay, some conditional. Look, here is also we are using the same way. Okay, say we are creating a class map maths telnet. You can give different name which one makes sense to you. But then look, math keyword. Math means if it is access group. Access group means ACL name, and then you mention the ACL name. Okay. Then it will be in the class name. That is the same thing. Okay, we repeated. Then okay, exit. Then class map and class, and then we call class. If you have programming knowledge, then it will not matter for you. Okay. Let's look. Okay, interface. Then we execute the policy. Service policy is there. Okay. Yeah. Now we'll see policy map. So all commands are running, it's good thing. Okay, you are seeing the telnet access control list, which is called access group here, and it is maths telnet class map, and this class map is in the policy input. Okay, so you can say okay, in this way you can check. Okay. Another thing, okay, cost is very simplified here, but it is not sufficient. But at least you understand how traffic are classified for cost treatment. Okay. Cost treatment, and we have another Syslog. Okay. Here is Syslog server. You have a router. Okay. You want to transfer logs from router and switches to log server. Okay. And that case you will configure. Okay. So use this topology, but I am just testing here. If there is any syslog, look, you have syslog server in this server. Okay, it is configured on. Okay. Now we will enable logging. Okay, network connectivity is okay. If you are doing with this topology, then configure in this way. Other, I'm just showing the logging trap. Okay, here it is important. Logging trap command is important in the server, in the router. Okay, maybe something wrong. Okay, logging, then what is there? No, it is in command, sorry, in command execution command. Okay, logging, then see logging, then trap. Okay, then question mark. But there should be, I don't know whether those commands are not. Okay, 0 to 7 should be shown. Okay, if don't know, actually they are not working as it should. Severity level just showing 7. Okay. Okay, in real router, what you will see, there are different levels of log. Okay. So logs are generated by routers and switch, and they have different levels. Say level look, 0 to 7. So what are the differences of this level? Level 1 means alerts. You are just given alert. It is not a critical condition, but you need immediate action. You need your immediate action needed. Say you router CPU is 90%. CPU utilization is 95%. So what will happen next? Maybe after some time, your CPU utilization will be 100, or you need more, and your some processing will be hampered. So your attention is needed to change your routers with a separate router which has more CPU capability. Okay. And you may have debugging how things are happening. Debugging. Why you use debugging? Okay, to see what is happening step by step. Okay. So for some message may come with regard to debug, and there can be critical condition. Okay. Say your router temperature is very high, and system is unstable, but somehow it is fluffing. So your link is fluffing. So it is severity level 0, and error condition informational. Informational is just you will be given some information. So your link is down to upper stage. So someone logged in. Okay, this type of information. Okay, just for your information. So how we can integrate say we are using this command. Okay. Logging, debugging. But one thing is that when you set 7, that means your 0 to 7, all logs will be there. If you set 5, then 0 to 5, all will be transferred to your server. Okay, that's good. Okay, debugging is working. Debugging. Okay, debugging level is, what is the level? Debugging is 7. Okay. And now specify the server. Okay, to which server you want to transfer your log. Here our server's log is 192.168.1.2. Okay. And do I need anything? Nothing. Okay. Now it is the show logging. Then what we will, let's try to change in the router something. So we just leave the interface VLAN 1 IP address okay. Okay. Now start if you run. Okay. Is there any log? I don't know whether it will be sent to server. Okay, look. Can you see that some information, some activities are there in the router, and router say system. Look, percentage system is system related issue. Okay, you have to read Syslog also. Percentage system, then 5 is level severity level 5, and what is severity level 5 in the list? In real router we'll see severity level 5 means system level. Okay, it is normal but significant condition, severity level 5, just notification. Okay, then we have received another log that is also level 5. It is link related. That is VLAN 1 switch virtual interface was up. Okay, change the state to up. It was down, it was up. So you are given a notification. Then severity level 6. What happened? Logging to host. So there is a host. This host is configured to a server. Okay, there is an important configuration. So it is level 6. Then configured from console by console. Okay. Console, someone is working on the console. So from a central server, you are seeing different logs. Okay. What is happening on every routers and switches or any devices that are capable of syslog can be seen here, and you can collect all the logs from all the devices and preserve here for investigation. Say something happened on your router, or from site someone is damaging or unauthorized logging is there, and configuring something unwanted, you can see here. Okay, this is syslog. Okay, so it is an important protocol that is used for router switch management. Okay, you should practice all those labs. Maybe some commands will not work in the packet tracer because of the limitation of this. Okay, you will get all the idea from this. Okay, do you have any questions? We should finish. So last day you asked about the link, the Google Drive. I am providing you the chat box. So you will get all the resources in this link. Okay. Yes, you had another question whether your quiz will happen when I discussed this with our training coordinator, or he told me that he will arrange a session. It is for awarding you the training completion certificate, and it will be in person. I don't know whether he will be able to arrange these. So he told me that he will confirm it. That is still not confirmed. So if they arrange in person session or finishing session, and in that case we will conduct this quiz in that session. That will be very good. And, okay. So did you copy the link?
Yes, sir.
Okay. You will get all the resources there. So already I uploaded previous sessions resources or materials if you miss, and upcoming and today's materials will be there also. Okay, do you have any questions or anything you can add, discuss, or we'll finish the session? And okay. Okay.
Sir,
Okay. Yes.
sir,
Yes.
meaning there will be no quiz, or you will just inform us?
No. Yesterday I told that normally it will be good actually if there is a small quiz. Actually, it may be MCQ based, which should be on your general concepts of different topics. It will not be that much difficult. Okay. I will confirm you. Okay.
Okay, sir.
Okay. Let's finish here. If you have no other issue or anything to discuss. Okay. Thank you all for joining. And anyone miss anything, then you can go to the recorded